All right, in this video, we're going to talk about complex numbers. So this is the second part of Unit 2. These are properties that we need you to memorize. And the first one is the letter I. So up until this point, you have not been able to take the square root of a negative number. But now you're going to be able to do that. So normally, the square root of 1 would just be 1. But when there's a negative on the inside, that's a special complex number called I for imaginary, okay? The next property you need to know is anytime you see I squared, that's going to equal -1. And here's why that works. So if the square root of -1 is the same thing as I, if I take that and square it, what happens when I square a square root is I just end up with the number on the inside. So that's why I squared is going to equal my -1. So just keep that property in mind as we go through. Okay, so let's look at some examples here. Taking the square root of -4. So if you want to just think about taking the square root of 4, normally you would say the square root of 4 is 2. And technically it's positive and -2, because if I multiply positive 2 times positive 2, I get 4. If I multiply -2 times -2, I also get 4. But because there's a negative inside the radical, anytime that happens, we are going to add an I to my answer. So we're going to go ahead and pause the video right now, and you're going to try examples 2 and 3. All right, so hopefully when you take the square root of -36, you're thinking again that's going to be plus or minus 6, because 6 times 6 gives you 36. And because there's a negative inside the radical, we're going to add an I at the end. Same thing with the square root of -100. We're going to say that's plus or minus 10, adding an I to the end. So these were all perfect squares. You get them by multiplying the same number by itself 2 times. 4, 5, and 6 are a little bit different. We're going to have to simplify these radicals. And here is how we're going to simplify the radicals. I'm going to pretend that this is just the square root of 20 to start off. And you're going to break down 20 until you get to all prime numbers. So think about what numbers multiply to give you 20. You can say 2 times 10, or you can say 4 times 5. It doesn't really matter. We're going to get to the same answer. So I'm just going to go with 4 times 5 here. 4 times 5 gives me 20. I'm going to stop anytime I see a prime number. And to remind you what a prime number is, it's a number that's not divisible by anything except itself and 1. 4, on the other hand, can be broken down a little bit more. 4 is also 2 times 2, and I'm going to stop at those prime numbers. Okay, so the way that it works to simplify radicals is if you have any pair of numbers, those numbers are going to come outside the radical as 1. So think of it as these two numbers were inside the radical, they're trying to break out of jail, but both of them are not going to make it out alive. So you're really sacrificing one, and only one of them gets out. And inside the radical, the poor 5 did not have a partner to escape with, so it's going to stay inside the radical. So the square root of 20 can be simplified to 2 square root of 5. Because there is a negative inside the radical, I want to make sure I add an I. Now you could add the I over here, but I personally like to write it in front of the radical, just so that I don't confuse that it's inside the radical. It's not. And then don't forget to add the plus or minus at the end. So the square root of -20 can also be rewritten as plus or minus 2i square root of 5. So again, we're going to pause the video here, and I want you to try 5 and 6, same idea. Your answer should have both a plus or minus, a radical, and probably an I somewhere for both of these. Okay, so we're going to break down 28, and 28 is 4 times 7. 7 is a prime number, so we stop right there, and 4 is 2 times 2. So 2 is a partner. They get to come outside. I know that I'm going to have an I somewhere because I took the square root of a negative number, so I'm going to go ahead and add it now. Don't forget your plus or minus. And then 7 was all by itself inside, so it doesn't get to go anywhere. And that is my simplified answer there. For number 6, I'm going to break down 50. So that's 2 times 25 2 is a prime number. 25 can be broken down a little bit more to 5 times 5. There is a pair of 5, so that's going to come outside. I know there's an I involved because I'm taking the square root of a negative number. And inside the radical, we have 2 by itself. Okay, so when we get to do the quadratic formula, you will be expected to break down these radicals. So please make sure that you are asking questions next time I see you if you have a problem doing this. Okay, so let's talk about what a complex number is. So a complex number has 2 parts to it. The first part is what you have worked with all of your life. It's real numbers. Okay, so these are integers using the number line from negative infinity to positive infinity. And then this is the new part, and these are going to be your imaginary numbers. And so when you are writing complex numbers out, you always want to put the real part first and the imaginary part second. Okay, so let's start simplifying some of these. First, we have 2 terms being added together. Technically, what you are doing here is you are distributing an invisible 1 that's in front of the parentheses. Once you distribute that 1, what ends up happening is the parentheses disappear. So 1 times 5 is 5, minus 1 times 3i is just 3i. I'm going to keep the plus the same. I'm just combining those like terms. And then here, technically, again, you are distributing that positive 1. So that leaves you with a minus 2 plus 4i. This right here can be simplified to just one math operation. So a minus, a plus and a minus next to each other can just simplify to a minus. And I'm just going to bring everything else down. And from here, it's just combining like terms. So use your calculator if you need to, but you're going to do 5 minus 2, which gives us 3. And then we have a negative 3i plus 4i, and that's going to give me a positive 1i. You don't necessarily need to write that 1 there. You might just see it as 3 plus i. All right, for the next problem, it's a similar concept. We just have a minus in front of the binomial. So here we have an imaginary 1 that when we distribute, it's going to give me the same thing, 7 plus I. And then here I'm technically distributing that negative. So negative times the 5 becomes a negative 5. Negative times a negative is going to become a positive, and that's a 4i. So you are going to combine your like terms here. So we have 7 minus 5, so just numbers with numbers. 7 minus 5 is 2. And then we have a 1i plus 4i gives me a total of 5i. So remember, as long as you are writing your real number first and then your imaginary number second, that's all you need to do there. So going to the back side, just doing some more operations here with complex numbers. We have this term 2 minus 5i being squared. So when it's being squared, it means it's being multiplied by itself 2 times. So now it's a multiplication problem. So the difference between this problem and the previous one is that these have a plus or a minus between them. So that's how I know I was combining like terms. But in number 3, I don't have a plus or minus between them, which means I'm going to do double distribution. So I'm multiplying 2 times 2, and I get 4. 2 times negative 5i. And for now, I just want you to think of the i's as x's. So just pretend these are x's, multiply it through. So 2 times the negative 5i is going to give me a minus 10i. Then I'm going to move on to the next term. Negative 5i times 2 is going to give me another negative 10i. And lastly, negative 5i times a negative 5i is going to be a positive 25. And I times I is going to become I squared. So we're going to combine like terms, the like terms that we can here. So again, if you pretend the i's are like x's, you have a negative 10i minus another 10i is going to become a minus 20i. I'm just going to bring down the 4 for now and bring this down. So a property that we learned at the beginning of this video is that anytime I see an I squared, I can actually replace that I squared with a negative 1. It's one of the properties we talked about. So this really becomes 25 times negative 1. And 25 times negative 1 gives you a negative 25. So I'm going to rewrite that. And then just go back and check. Can you combine anything else to simplify this problem? You really should only have two terms, a real number and an imaginary number. So I can combine the 4 minus 25. 4 minus 25 is a negative 21. And I still have my minus 20i, giving me my final answer. So remember to write the real number first. So for number 4, we're going to do the same thing. Remember, the squared means that you are going to multiply this term by itself. 3 minus 7i times 3 minus 7i. So I'm going to go ahead and multiply 3 times 3, and that's 9. 3 times negative 7i is a negative 21i. Then I'm going to go on to the next term. Negative 7i times 3 gives me a negative 21i again. And negative 7i times negative 7i is positive. 7 times 7 is 49. I times I is I squared. So go ahead and go through combine like terms. We have i's here. Negative 21i minus 21i is going to become more negative, giving me a negative 42i. Then I still have that 9 in the front, and then plus 49. Remember, anytime you see an I squared, you're going to replace that with a negative 1. So 49 times a negative 1 makes it a negative 49. And then bring everything else down. One more combining like terms here. I can combine my number 9 minus 49. Gives me a negative 40. And then I have a plus 42i. All right, and the last part of the notes, we're going to talk about a new vocabulary word, and that is the conjugate. And the conjugate is going to be the opposite sign of our imaginary number. So we're going to use the conjugate to multiply the bottom of the fraction to get rid of the denominator, an imaginary number in the denominator. So there's a rule in math that says we don't like imaginary numbers in the denominator. So in order to get rid of that imaginary number, I have to multiply by the conjugate. So in this example, I have a plus bi. The conjugate of that is going to be the exact same real value, so a is going to stay the same. And then whatever I have for my imaginary part, because it was positive, the conjugate of it is going to be negative. So with numbers, this would be something like 5 plus 2i. If I ask you to multiply by the conjugate, you keep the real number the same, but the imaginary portion is going to be the opposite sign. So this would be the conjugate of 5 plus 2i. Okay, so we're going to try this. Our first example here, we have 6 plus 2i divided by 2 minus I. So again, looking at the denominator, I can't have any imaginary numbers in the denominator. So I'm going to multiply by the conjugate of that denominator. The conjugate here would be 2 plus I. So again, you're only changing the sign for the imaginary portion of that complex number. And whatever you multiply the denominator by, you want to multiply the numerator by the exact same thing. So it's kind of like an equation. Whatever you do to one side, you do to the other. So we're going to do the same thing to both the top and the bottom of this fraction so that we're not changing the actual value here. Okay, so I like to split these up. I'm going to show you the multiplication for the numerator here. And then we're going to do the denominator separately, just because it can be a lot. It can get kind of messy. So the numerator is this part right here. And what that part is showing me is that I'm multiplying 6 plus 2i times 2 plus I. And we just practiced a problem like this earlier in the notes. So I'm going to take this problem and I'm going to start double distribution. So 6 times 2 is 12, plus 6 times I is 6I. Then I'm going to do the second term. 2I times 2 is positive 4I. And 2I times I is a positive 2I squared. We are going to combine like terms here. I can combine my i's together. So that's going to give me a 10I. I'm going to bring down, that's a positive 10I. I'm going to bring down the 12. And then remember the I squared right here, that's a property that I can turn into a negative 1. So this can be simplified. 2 times negative 1 is going to be a minus 2. And then bring down everything else. My last thing that I can combine are my numbers. So we have a 12 minus 2, which gives me 10, and then the imaginary portion. So this is going to be my new numerator. So when I multiply things through, my numerator here is 10 plus 10I. So I did all that work just for the numerator. Now I'm going to do all that work, but for the denominator. So that's why I personally like to split them up. That way it kind of keeps things clean here. So for the denominator, I'm multiplying these two things together. So I have 2 minus I times 2 plus I. And we're going to do double distribution here again. So 2 times 2 is 4. 2 times I is 2I. Negative I times 2 is a minus 2I. Negative I times positive I is a minus I squared. So something that should always happen in your denominator when you multiply through the denominator, you should always end up with something like this. A 2I minus a 2I, they're going to end up canceling out because they're the same number but with opposite signs. That's the whole point of multiplying by the conjugate. So if the i's are not canceling out somehow in your denominator, you need to go back and look at it, make sure your multiplication is done correctly. So I'm going to bring down this 4, and then I have a minus. Anytime you see that I squared, that means negative 1. Now please be careful, there was already a minus there, so I have to include both that minus and the negative and the property that I squared is negative 1. This can be simplified as 2 negatives next to each other give me a positive, and 1 equals 5. So that's my new denominator. Okay, so again, split it up just to kind of stay organized. Now, before we can say that we are done, you always want to go back and check, see if any of these terms, the numbers themselves, have anything in common that you can divide out. Okay, so if you can simplify, please do. In this case, when I look at 10, 10, and 5 in the denominator, I can see that they are all divisible by 5. So what you're going to want to do is divide all those numbers by 5. When I divide 10 by 5, I get a 2. The 10i by 5, I get another 2, and don't forget your I. And then 5 divided by 5 is technically 1. You can definitely leave the 1 in the denominator, or you can just write it as the 1 term, just the numerator, because anything divided by 1 is itself. Okay, so this last one, I want you to go ahead, let's pause the video and see if you can do this one on your own. Remember, you only need to worry about the conjugate of the denominator, and you're going to use that same number for both the numerator and the denominator. So let's pause now and give you a few moments to try it. Okay, so hopefully you tried this. Your conjugate here should be a 4 plus 3i, and that same number is going to be used for both the numerator and the denominator. Once you have identified your conjugate and you go ahead and show that you're going to multiply it to both the numerator and denominator, I suggest you split it up. So I'm going to look at my numerator, and my numerator is me multiplying negative 3 plus I times 4 plus 3i. And then I'm going to do double distribution here. So negative 3 times 4 is a negative 12. Negative 3 times 3i is a minus 9i. I times 4 is 4i. I times 3i is 3i squared. Combine your like terms, the negative 9i plus the 4i is a minus 5i. Highly suggest you use that calculator so you don't make the small mistakes. And then remember your property, anytime you see an I squared, we're going to replace it with, in parentheses, a negative 1. 3 times negative 1 is going to become a negative 3. And I'm going to bring everything else down. And then I can combine my numbers. Negative 12 minus 3 becomes more negative. So that's a negative 15 minus 5i. So again, that is your new numerator. Okay. And we're going to do the same thing with our denominator. My denominator is 4 minus 3i times 4 plus 3i. And this denominator, remember our goal is to cancel out I, so you should be canceling out just your I terms here. So that's a good way to check if you're on the right track. So we have 4 times 4 is 16. 4 times a positive 3i is a positive 12i. Negative 3i times 4 is a minus 12i. And negative 3i times positive 3i is a minus 9i squared. So here it is. Here are the terms that should cancel out because they're the same term, but just opposite signs. So I'm going to cancel those out. That leaves me with a 16 here, a minus 9, and then replace that negative 1. So always replace just the I squared with the negative 1. This can simplify to a positive 9, and 16 plus 9 is 25. That's your denominator, 25. Another way to check that you're doing this right, if you still have any i's left over in your denominator, you know you got to go back and check your work. The whole point of multiplying everything through is so there's no longer i's in the denominator. So make sure that you check for that. Okay, and the last step here is going to be to simplify. So is there anything that I can divide out for all these terms? That's what you're kind of asking yourself. Okay, and I know that 5 goes into all of these. So you're dividing the whole thing by 5. So 15 divided by 5 gives me a 3. Keep the negative there. 5 divided by 5 is 1. You can put a 1 in front of it or just I. And then 25 divided by 5 gives me a 5 as my answer.